here we are again with the Ohm's law solver, the simple example I had initially, and I hope not to knock this again as I did last time. And what I've done now is I've added an extra wrap around it. It's got the extra precision in there down to the nanoamps and the microvolts, etc., milliamps. And what I've done is basically use the ANSI screen up the top here of the video. As you can see, it's just representing the display. We could have an LCD display, a character display, or anything. And then we could also have a physical dedicated keypad, just buttons, a matrix perhaps. In this case, I'm just using a keypad that's plugged into my PC as part of the terminal. I've labeled some of the keys, and they're the ones I go and execute these particular actions. You may remember in the original code, I had milliamps, I had millivolts. There they are, and that calls it up directly. I've got R as well, and another one I'll show you later on. So here we go. First off, every number we punch in is just accumulated. We just basically accumulate a number on the stack with this one, so it's not a normal console input. 3, 3, when we get the correct input, which we will get in just a moment. 3, 0, 0 millivolts. There we go. 3.3 volts, and we're going to aim for 20 milliamps. There we go, 20 milliamps. And what's the resistance for that? 165 ohms. Now, if I really want 20 milliamps, I don't need 20 milliamps, but in this case, I'll need 165 ohms, but I don't have 165 ohms. But I do have a 220 ohm resistor. What resistor would I need to add in parallel to that? Well, it tells me that I need 659 ohms, or 680 is pretty close because we do a 680 instead, and it says, yeah, 217 in parallel, you know, so 220, and that'll get pretty close to that. And I suppose I could add that in, so take that into account. So that just gives, I can zero that one out, get rid of that. So that's just handy parallel resistance calculator. I could put in the standard E96 values, all that sort of stuff, but this is easy enough. I can see what's here. And now we're going to see if we can go to 220 ohms. Anyway, just go to 220 ohms, and how much current, well actually, what voltage would we need to get 20 milliamps? Well, it tells us we need 4.4 volts at 220 ohms to get 20 milliamps. But in this case, we just want 3.3 volts, and we don't care. How many milliamps do we get? 15. Not a problem. In fact, we've put an LED in series with red LED in series with the it's not 1.8 volts. 1.8 volts for the LED, but from 3.3 leaves 1.5 volts. So there's 1.5 volts there. And how much current do we get? 6.8. More than enough for most LEDs. Most LEDs only need 3 to 5 milliamps. The 20 milliamps was always the reference figure they used in the really, really early LEDs. So that's a bit of a quick demonstration, just showing you that what you can do. But obviously, it's more fun if you can actually make a dedicated instrument with the C3, with your own keypad being scanned or whatever, serial maybe, and then going out to an LCD as well. That might be the next one I do. Okay.